Hello, everyone, and thank you for joining us today on our AskTom Multicloud happenings. This is a really brand new AskTom session. We had our first session last month, and we welcome you or encourage you to go take a look at the first recording. So we're going to be having this AskTom session every month to bring you multi-cloud happenings. So today we thought we'd talk to you about application performance considerations in a multi-cloud split stack architecture, because really it's all about running your application and making sure you get the best performance, right? Everybody's always concerned about that, no matter where the application runs, but especially within a multi-cloud environment. So my name is Tammy. My name is Tammy Bednar, and I focus on our Exadata database service and our base database service. And my other co-presenter with me that really leads the multi-cloud happenings is Suzanne Holliday. Hey, Suzanne.
Hey, Tammy.
So we're so glad that Suzanne could join us today, and she's really leading our effort for our multi-cloud solutions and architectures. And so I call her Miss Multi-Cloud because she knows all about multi-cloud, and she's really has a really great experience with Oracle and understands a lot of the networking interworkings with multi-cloud. So if you ever have any questions about multi-cloud, please reach out to us, and especially Suzanne, because she is a wealth of knowledge. So, but today we have a special guest, is Connor McDonald. Connor is, I hope, well known to most of you and many of you, especially within our SQL developer area. And we are so lucky to have Connor today. Hey, Connor, thanks for joining us.
Glad to be here. Just coming up to Christmas. It's good to catch up with friends from overseas. So.
It is definitely great to catch up. Yes, I know I have my little Christmas background. I had to put it on today because I'm all excited about Christmas is just right around the corner. So, Connor, you've been around Oracle for quite a few years, right?
I've been an Oracle employee since 2015.
Okay.
But I often talk about people in terms of when they're Oracle, in terms of their version. So I'm an Oracle 6 baby.
Okay.
So that was sort of early 90s.
Yes.
So yeah, I was a part of a company where we adopted Oracle in Australia, one of the very first people to really adopt Oracle in Australia. And so we had all the joys of early versions of Oracle. But yeah, so playing with Oracle since the sort of early 90s, and then finally decided, well, the best place to enjoy Oracle tech is actually inside Oracle. So I joined in 2015.
I really love the fact that you always talk about, you relate the version to when you actually started working with Oracle. I think that's amazing, because I listened to your Dom Giles podcast, and I'm afraid I have to burst the bubble here, because two of you were not down with the 734, and I'm a 734 baby. So it's the revered release, but you had some wise words of wisdom as well on Oracle 6 to add. So I really enjoyed that podcast with you and Dom. I thought it was super interesting.
Wow, thank you.
So as we go through our AskTom session today, please post your questions into Q&A, and we'll be happy to address those as well. So let's go back to what our topic is today, really about application performance, especially in multi-cloud. And there's something that we call an anti-pattern impact on application performance. So Suzanne, what does anti-pattern mean?
It sounds like the Antichrist, doesn't it? Well,
let's not talk about that during Advent season.
No, quite. So I think in the anti-pattern, it's very much a design pattern that reverse. So it's negative. It's about common defective processes and implementations that actually happen as a result through bad designs or let's say unexpected problems that may manifest under certain conditions. So what that means, that you could see that there are some common if you will, design flaws that may lead to such as scalability problems, especially when applications are under pressure, and especially when you really don't want them to happen is when they especially manifest. So I think today what we really want to talk about is how this is relevant and how we want to tie everything together with multi-cloud, especially multi-cloud on a split architecture, meaning the application will reside in one cloud while the database, in our case, would be on Oracle Cloud Infrastructure. And what we see is customers, move to the cloud, and the application will sit very close, typically, to the database. And this is why it's so exciting to have Connor on here today, because what we want to show you and really talk about is that when you actually separate the application from the database and through distance, because obviously when we put it on a split stack, it's no longer side by side anymore. And you'll see sometimes that maybe some unexpected behaviors show up that you didn't really envisage. And then that's the first thing that you need to look at. So what is this behavior that's happening now as a result of a different implementation? And secondly, how do we fix it? So
Right.
This is Connor's come in and he's going to give us some examples of how we can identify, let's say, latency sensitive applications. Latency plays a huge part of this. And I think especially when you're looking at typical traits, right, of what happens with anti-patterns. I know that Connor, I think you discussed that you were going to show Chatty IO, right? On the
that's definitely one of the things. Although I will start off with a little thing. It's one of the things I've seen on Twitter recently is people love to jump on the bandwagon that multi-cloud is not going to work for any application, etc. And that's basically fiction. And one of the interesting things I find is when we talk about pertaining to latency, is I'm always amazed how people can have their blinkers on in terms of when they talk about their own data centers, cloud data centers, and hence multi-cloud. It's funny how, and Suzanne, you'll talk to this, I'm sure, shortly about what we offer in terms of latency on our multi-cloud offerings. And yet I'm always amazed how many data centers I've visited for customers when we do some performance monitoring, that the latencies we see inside their own data centers are far and away more than what we see in cloud environments, even multi-cloud environments.
That is
simply
so
because on-premises data centers generally evolve over decades of growth, and often you'll see things like file and print sharing the same communication channels as database and applications. We'll see, even public networks inside the data center sharing those with what are meant to be private networks, etc. So, in terms of talking about latency, one of the things that I think people need to come into any kind of thing with is with an open mind, in the sense that people often come closed in saying, oh my goodness, if I was to go a multi-cloud environment, then latency is going to be the first and foremost things I need to be aware of.
Right.
And don't get me wrong, we always should be mindful of latency, but I think people should be very focused on what their current latencies are, however their database architecture is set up, before they start going, oh, well, I have concerns about moving to either a cloud or multi-cloud environment. So that's probably the first thing I'd want to say in terms of latency. Having said that,
I agree. Sorry, Connor, carry on.
No, you. But in terms of that, one of the things that I view separation between application and database is, I think of it like a stereo amplifier. If you have a exceptional, a well-crafted application, then latency generally doesn't have much of an impact on your application.
Right.
But by definition, it must have some impact, but it's often negligible. However, if you have a bad application, then latency acts like a magnifier. Bad applications will look worse. And there are mitigations you can take to solve that. But I think the first thing we need to do is be open and honest with our applications. What kind of quality do they have? All applications should be built with latency in mind, no matter what their architecture. Often that's not the case, but we can look at some examples of where these things might be important to look at. Funnily enough, the most obvious amplification of a bad application will be unrelated to latency, and that is if your application, any application running on Oracle, if it's not using bind variables, then that will be the dominant performance overhead. So anyone with an application that's not using bind variables, they can feel free to run it on premises, on our cloud, on multi-cloud, because it's going to run badly in all cases. And it's fair to say it's already running badly, and moving it to a cloud environment won't be some magic silver bullet that'll make it run better. In fact, even throwing server horsepower at it won't make it run better. So we'll conduct the rest of this session assuming that people have at least crossed that first hurdle of using bind variables in their application, because performance, funnily enough, isn't even the main issue if they're not using bind variables. Sure as night follows day, if you're not using bind variables, you're going to get hacked. And that's obviously in no one's interests. I'd love to say that, as Oracle representative, we're putting our philanthropic, good-natured heart on, saying we don't want you to get hacked. But the reality is we have skin in the game. No one wants to be a customer or a vendor that's on the front page of the news going, yes, customer X was running Oracle and they got hacked. That doesn't look good for any of us.
No.
So we'll assume that people definitely have crossed that bridge, because all bets are off if they're not using bind variables. So.
Right. Yeah. I mean, there's so many different causes, and you would quite rightly say you have to really ensure design is first and foremost from the start, irrespective of where it's deployed in the application. And this is why we say, even with the OCI Azure solutions that we have, whether that's the interconnect or Oracle Database Service for Azure, we always recommend that customers test their applications as a proof of concepts, because we can't tally this latency, this average latency that we we'll stand up a data center in close proximity to Azure as part of this interoperability and the Oracle Azure partnership. But to your point, Connor, if we get the 2 millisecond latency, it doesn't give it the seal of approval and the stamp to say, hey, your application is going to fly and everything's going to be fine. And this is why we always say test, because we see customers sometimes where they'll put the application on and, there'll be, design flaws, different causes, extraneous fetching patterns, where there's just too many round trips going on. There's too much back and forth. And yeah, sure, there probably was that on premise, but when it's within closer proximity, you're going to see maybe different results as well. And whether you're going to cache the data or not, and everything around I/O and things, which I'm sure you're going to take us through.
Okay. So you mentioned there.
Oh, go ahead. Go ahead.
You go, Tammy.
No, please go ahead, Connor.
So you mentioned there 2 millisecond latency. So I did a bit of playing around this afternoon. This may or may not work. I tried to set up my home network. So I've got the laptop we're currently on Zoom. I have a second laptop across the room, and I've hooked them up by Wi-Fi, hopefully in the aim that they will give us about a 1 millisecond latency. So I sort of routed a few gateways and stuff like that. So to try that. So let me just get that window up.
Yeah, you do that. Sorry, Tammy, go ahead. You wanted to...
No, I was going to say, this is a great conversation on application performance and Antipatterns, but maybe we want to take a look at what we have available in the console as well. Cool. So that it kind of exposes the information. Yeah, go ahead, Connor. We'll go ahead and chat about this for a minute, and then we're going to turn over to you, Connor, and go from there.
So I think what we also would try to help customers with is network planning and so forth.
Right.
Very, very important. And irrespective of what you're doing, where you're at, whether you're just even on an OCI, of course, within multiple regions. And this bears great importance for backups, for failover situations, disaster recovery. And really, at the end of the day, the fiber is routed under the sea and takes certain paths, right? Obviously, not always where the crow flies. So we really need to take care of the latency that we probably may expect to get between certain regions. And this is where the inter-region latency dashboard comes in the OCI console. And that really gives our customers the ability to view in real time, as well as historical latency for all the OCI regions around the globe. And I say it's for OCI, but as I just said, the fiber's laid the way it's laid. And you can probably look at the latency we're getting, and I've compared this as well with the Azure table they have for their latency excuse me, for their latency checker, and there are, you know, pretty much very similar millisecond readings for between the regions. So you can see here it's like this grid format. So you've got columns and rows, and where your meet is what your latency will be. In the middle, it's this grid format, right? And then you've got like these regional pairs so you can nicely see that. And then, you know, but it's really important to say this is not specific to your tenancies workload, of course, right? You know, these are global statistics, and they provide, you know, visibility into latency between all your regions. So like I said, that can help you in many scenarios. And another really, really interesting tool that we have on OCI is Network Path Analyzer. And what that does, it will collect and it will analyze the network configuration. And I think it's very, very cool because it really determines how the network paths between the source and the destination, whether they function, whether they work, or whether they'll fail. And you know, it's not actually done on real traffic being sent, but it's about the configuration that's examined itself. So what Network Performance Analyzer does, it will carefully examine and route, you know, all your routing and your security configurations, and it will identify that potential network path, and it will, you know, how the traffic will actually traverse. So whether this is virtual networking entities, etc., in the path, and it does all these checks on routing rules and network access. So I really would recommend customers to try that if they've not actually seen that before.
Excellent.
Okay.
So Connor, you're ready to show us some examples of how we can look at latency or some best practices?
Let me just do a couple of slides. I'm going to seize the slides. That's okay. So here's a simple. I'm going to start with a really, really basic app, which is almost like the worst case scenario, and we'll see it's a trivial app, but we'll actually map it into a very common use case we see in real applications. So this is my trivial app, and I've simply grabbed a snapshot of the code, and it's simply doing a simple query on a primary key. So it's a one-row lookup, and I've got 20,000 times here. This was for an original demo. I've dropped it down to 5,000 for tonight because I'm running over this simulated 1 millisecond network. So that's all I'm going to do. So let's just go to my second window. Hopefully you can all see that, and the font's big enough. So this hopefully should validate the fact that my home network here that I've set up is about maybe just slightly over 1 millisecond. So it did 5,000 primary key lookups from a Java application running on this machine to another machine running an Oracle database across this network. And we can see the 5,000 calls took about 6.1 seconds, so about 1.2 milliseconds per call. We'll come back to the database CPU later. So heading back to the slides, earlier on today, I put a trace on this activity, and this tracing is perhaps your first port of call in terms of really digging down into how we can identify latency in an application. So here's the query. Select a column from, in this case, my demo table where the primary key equals some bind variable. As I said, we always pass in bind variables, otherwise this whole demo would be a moot point because you'll get hacked and you'll be out of business. But we can see the actual total time the database spent doing this entire workload, I think I highlighted it, is about 0.16 of a second. So that's how much the database was involved in the 6.1 seconds of this activity. And so the question is, where did the rest of the time go? And that's why tracing is very, very useful in this particular scenario, because the tracing information reveals where the time was lost or spent elsewhere. And the key ones you'll find when it comes to digging into latency is this one, SQLnet message from client. To client is also relevant, but to client is effectively the database sending information back, and from client is the database waiting for the client to send it a request. And so generally it's the request being sent over the line that is what we are most interested in when it comes to latency. So I did 5,000 queries, 5,000 individual requests from my Java application. So we actually did 5,000 times the database waited for us. So the database did some work and said, what do you want to do? And effectively it was waiting while the results came back to us. We processed them and then sent the next request off. And we can see out of our, in this case, just over 5 seconds, 5 seconds was spent actually going back and forth across the network as compared to, if I go back one, 0.1 of a second. So in this case, like literally 99% of the time was spent going back and forth across the network. Let me stop my share.
Can I just say, Hannah, I think that is really, really helpful, because when customers have to make that decision and they have to look at which applications are going to run well on a split stack architecture, any tips and advice that you can share to help them on that journey is really valuable. I know that customers have asked this to us recently, and we get this quite a lot, because you imagine they have this huge estate of applications. They can't know every single one inside and out, but then they have to make that architecture call. So thanks for sharing this.
That's okay. Now, I'm hoping that created some alarm bells in people's minds. They're going, oh my God, like I actually achieved 0.16 seconds of work, but it took me 5 seconds to do it. And people are, hopefully not leaving the call right now, but basically not screaming to the hills going, oh my God, latency is going to kill us. But I put that deliberately so we can talk about the various scenarios in which people should be considering their applications and whether they'll actually be genuinely latency sensitive. That application there looks incredibly latency sensitive, but I'm going to present an argument now that says it might not be. So that was the simplest form of database application we could think of, a primary key lookup. Everything comes in with a key, we do a lookup, we get a row back. And we saw there we did 5,000 of them, and we start to panic because it took so long. However, very few applications out there do 5,000 primary key lookups to satisfy a task or a function. Across thousands of users, you might be doing thousands of primary key lookups. But in terms of satisfying a particular function, it might be just 1, 2, or 3. Get me the customer details, get me their account details, get me their current balance, etc. So from an individual customer's perspective, an application user of your system, if your application is doing a smattering of key lookups, then across the entire landscape, it looks like we're losing time. But as long as network bandwidth is sufficient, which rest assured on any cloud offering is going to be the case, then if each individual's experience is just a smattering of primary key lookups, then yes, they're encountering a latency overhead, but that latency overhead will be a response time going from 1 millisecond to 4 milliseconds. From a user's perspective, that's the same. Ultimately, if it's anything more than, say, half a second, might be cause for concern in a OLTP style environment. But from a single user's perspective, and therefore a collective user's perspective, response times drifting out from 1 milliseconds to 3 milliseconds is not noticeable. They simply won't notice that. And so ultimately, even though it looks like small key lookups might be an issue, it's not. Conversely, if you have an application that does do to achieve one task, hundreds or thousands of small queries and key lookups, then yes, that's going to be a problem. It's already a problem in your data center, and it's going to be a bigger problem the more you increase the latency. And so, but I wanted to set that tone. The first thing, that if you're doing lots of primary key lookups, there's a very good chance that latency is still not an issue for you because you're doing a small number of them. But if you're doing lots and lots and lots of key lookups to satisfy a single task, then you could be in trouble. Now, stop me if I'm ranting too long, because otherwise I'll just keep going. But probably the most common example I see of applications that fall into that dangerous second half are, and I hate to be banging on the OO people, but systems related to object-oriented architectures, often Java, C#, etc., where we have hidden database access inside, either directly inside our own objects or inside an object management layer, like ORM, etc. Don't get me wrong, I don't want to crap on ORMs. ORMs are fantastic, but their primary use case was solving the object impedance mismatch. We want to get relational data, but we want to present it to the application as objects. ORMs are beautiful for that. Unfortunately, people then took that and just ran with it and ran like hell with it and turned it into every key piece of data that we want to ever access. Well, we'll just wrap it in some sort of ORM call, and we don't really care where it comes from because the ORM takes care of it for us. So all of a sudden, to present a customer view on the screen, unbeknown to the application developer, they're just saying, go get me this customer object. But the ORM behind the scenes is doing, get me the customer name. That's a query. Get me the customer surname. That's a query. Get me their date of birth. Get me their account balance. Get me their address. Get me their zip code. Get me their gender. And what could have been done in a simple single trip to the database, perhaps with a simple SQL query or a pure SQL call, is now doing 30, 40, 50, 100 trips to the database, each one getting particular attributes. In fact, one of the anti-patterns that's listed in the list you popped up before was the concept of repeatedly fetching the same information that could have been fetched in a single call. So anyone writing OO systems and you've very strongly or densely abstracted away the database access, they're the ones that I think are often risks, because you end up doing countless trips to the database, countless unnecessary trips to the database in order to satisfy simple functions. So they're ones to be very, very cautious of. Continuing on, as I said, interrupt me if I, and same with attendees, interrupt me if I start getting boring. One of the things that you do often see applications doing lots and lots and lots of queries to the database, even then, does not necessarily mean it might be a latency issue. So I've mentioned small number of primary key lookups or key lookups, not a drama. OLTP systems will run fine no matter what the latency is within reason. And certainly if it's in the millisecond reason, they'll be fine. Systems running ORM systems where they're doing unnecessary large volumes of key lookups, they're going to have some dramas because they're still trying to satisfy the response time for a single function. The third one is programs we look at and we see they're doing countless thousands of SQL calls, but they might not be an issue. And the most common example of that is anything which is done asynchronously to the user. Batch jobs, the most common examples, anything which is doing analytic style work, anything which might involve thousands of queries to the database, but isn't being done as a time critical component to the user. If you move to a system which has higher latency and you have a program that's doing 10,000 trips across the network to database calls, if it's currently taking 1 hour in your data center and you move it to some other architecture and it takes 2 hours, the odds are you don't care, because the reality is anything that takes 1 hour isn't being sit and watched by someone anyway. It's effectively being done asynchronously. It's an overnight batch. It's been run by our scheduler. It's been run by some other external third-party scheduler. It's very rare that things that run for tens of minutes can't afford to run for 10 more minutes in these cases. And it only becomes a case if you have programs which have a very large batch window that run, yet their batch window is 8 hours and they're currently running for 7 hours 50, then yes, that might become an issue, but you've already got concerns there anyway, because if you're running that close to the wire, you're already, I would imagine, encountering problems on occasional basis. But so just because you're doing thousands of database calls doesn't necessarily mean, once again, that higher latency is going to be an issue. If those programs are asynchronous, then not going to be a big drama. And even if latency is an issue for such programs, a common technique to overcome these things, because of bandwidth is so much more available than latency concerns, is to parallelize those operations. And a common example is I know customers that you're doing a nightly job for every customer account. You might be updating their trend analysis scores, their buying patterns, etc. It's generally fairly easy to take jobs which are looping through every single customer one at a time through your 100,000 customer base and split that into 2 jobs, each one running for the 50,000 customers, or 10 jobs, each one running 10,000 customers. In that case, once again, latency concerns are mitigated because you can parallelize a job that was currently running close to execution window times. So I suppose to summarize that very lengthy set of sentences I made, it's amazing how often an increase in latency is actually something that isn't necessarily a large concern. But so the first thing that customers need to do when they're looking at environments that might move to latency sensitive environments are, how can we categorize each of our applications? If it's batch, it's unlikely to be a big drama. If it's small OTP transactions, it's unlikely to be a big drama. It's poorly architected applications, for example, sitting mistaken usage of an ORM or some similar kind of mechanism where they're doing too many calls, or applications that do so many calls and cannot be parallelized or made asynchronous. So all of a sudden, the good news is for customers that rather than having to look at this much application landscape, there's a very good chance that you only have to focus on this parts of your application. They're the ones that you need to take care with and maybe need to do a bit of work on when it comes to moving to multi-cloud to get all the other benefits that come with multi-cloud.
I like that, Connor. Being
I
able
should take
to,
a breath.
yeah, no, being able to look at just a small chunk, that is a great thing. I mean, because I think sometimes we all get overwhelmed if we feel like there's a really big task that we have to do. And so I think you put it very well just by looking at a smaller chunk of really what you're trying to execute, and possibly update in order to make it work much better within for your application latency, to fix that application latency piece. So that's a really good point. I like that.
And just really categorizing it, that method of going through everything and putting it into categories. Yeah.
Yeah, no, that's a great idea.
Okay, I'll give you a couple ideas for what they could look on if they're doing some tracing and they want to try work out whether they should categorize things. Let me fire up a couple more slides. Once I find my Zoom button again. And I wanted to stress this point because anyone on the call that's technically minded has probably used SQL Trace in the past, or they've used any of the wealth of other tools that we have that effectively dive into wait events, AWR reports, active session history, etc. And one of the common things that we see across all of those things is that we say, when you're doing performance tuning, if you see SQL net message from client, then that's an idle wait and doesn't need to be of concern when it comes to database tuning. And that's true to a degree, but it's also very useful in terms of becoming a tool. So I want to dispute that fallacy first, and then we'll talk about how you can actually look at trace data to come up with ideas for how you can categorize applications. So during my very poor artistic skills, we've got time traveling across the screen here. And let's say I want to do some tracing, whether I'm using tracing like we saw here, actually using raw trace data, or whether you're using active session history, or whether you're looking at an AWR report. AWR reports are perhaps a little bit dangerous because they tend to summarize the data a little bit too much. But if I turn a trace on, what tends to happen is when a task is getting to start, ready to start, normally I will have turned a trace on just before that. And whether tracing is on or not, one of the things the database does is obviously the moment you create a connection to the database, whether it's you as a user or an application does, the first thing the database does after serving your connection is it says, well, I'm waiting on you now. I'm just going to sit here and do nothing until you give me some work to do. And the way it records that is SQLnet message from client. I'm waiting from you, from the client, to send me a message. And that's why while we're waiting for a task to start, this first part here, it is truly an idle event. This 10 seconds here is not the database suffering, it's not the client suffering, it's literally both client and database doing nothing. And this is why we often say, if you see SQLnet message from client, then we consider it an idle wait. It's nothing to be concerned about. Similarly, then your task runs for a while and it ends. And once the task ends, the database once again sits there and waits. And until you turn tracing off, or you stop monitoring or stop looking, all that time after the task ends is also idle time. The database is doing nothing, your task is finished, you have no interest in it. However, between task start and task end, obviously, especially if your application is running not on the database server directly, which is going to be 99% of them, it's regularly making calls to the database. It's doing some work, then making a call, doing some work, making a call, etc. All the time that's spent not interacting with the database will be recorded as SQLnet message from client as well, because from the database's perspective, you're not interested in me. So your task starts, we do a little bit of work on the client, and then we make a database call. A little bit more work on the client, make a database call, etc. My argument here is that historically we've said these are idle as well, because the database is not actively doing work. However, in reality, I view these as they probably shouldn't be treated as idle, because they also are a reflection of the time spent getting back and forth to the database. And so what we want to be looking when we're characterizing applications is we want to record at the application layer, how long does a task take to run? And then between those times, we want to look at our SQLnet waits there, and that's going to give us a good indication of how the latency is impacting this application. And the way we can look at doing it is if we see lots and lots of very, very small waits, then it's most likely a latency issue. And we're talking about waits in the millisecond range. These ones here will typically be in the seconds, tens of seconds of time. Anything very, very large in the seconds range or above is probably genuinely an idle event, because it either means it was before the task started, after the task ends, or if it's somewhere in here, it means the application itself is busy doing its own work and not involving the database. If we're capturing lots of SQLnet message from client events, but they're all typically in the 1 to 2 millisecond range, that's a very good indicator that your application was, as soon as it had finished doing a database call, it was moving on to the next database call. And so when you're doing some profiling, you can look at your summarized figures. Am I doing, how many SQLnet message weights did I do? Were they small? Were they very, very tiny weights? If they are, then they're generally probably going to have a direct impact on response time. If they're lengthy, if they're anything generally more than the measurable network latency, so if your network latency is 2 milliseconds, but these SQLnet message things were 10, 20, 30 milliseconds, then the likelihood is then you weren't being impacted by latency at all. Your application is doing work in its own sort of application space and not interacting with the database. And that gives you a good confidence that actually you could migrate that application onto a multi-cloud environment and the latency is not going to be such a large issue. So that's the idle fallacy I wanted to tick over. Anything you want to jump in there before I move on? Okay, so the next thing in terms of solving this, let's say I've done some work and I've said, okay, yep, I found out that, like my primary key example, I'm doing 5,000 calls to the database and it's costing me a lot of time. How can I mitigate that? Well, let's now elevate that application to something perhaps a little bit more realistic, because most applications just don't do single primary key lookups. So I've now expanded my application to do something which I'll call a little bit more realistic. It's going to do what we would typically do in, say, a Java application or similar. This time I'm going to loop around 20,000 times, but in this case I'm doing some task 20,000 times. I think I just did it. I think I'm only did it 5,000 in this demo. But so this time we're doing 3 queries. I'm getting the region ID for a particular customer, I'm getting the order ID, and I'm getting a count star of order items for a particular order. These are just 3 random queries against a sample schema I have, but they're representative of what a more typical application would look like. They need to do 3 trips to the database to get some information. And because we're using ORM or we're using JDBC or we've written the code, or as developers we're more familiar with Java than we are any other language, then we're going to simply race off to the database 3 times to achieve this task. So let me bring back my window here and reshare it so you can actually see it. That'll be useful. Not sure how this will run because we've got Zoom running as well in the network and I'm sharing video, but we'll see how we go. Hopefully it won't be too long. It might be. We'll see how we go. Come on. There we go. So 16 seconds. So yes, I had reduced it to 5,000. So once again, this probably makes a reasonable amount of sense. I tried to hook this network together so it's about 1 millisecond latency. We did 5,000 iterations of the task. Each task consisted of 3 SQL statements, and therefore we got about 15,000 calls, just over 1 millisecond per call. I'm glad my Wi-Fi setup is delivering as I promised it to do. So the question is, how can we improve this? Like, I've got to do, obviously, I'm doing 5,000 iterations. I've got to do the 3 queries. So in terms of a developer now saying, I want to take advantage of multi-cloud to get all the other benefits, how do I improve this? Because this definitely is being affected by latency. Let's go back to my slides. So here is literally a trivial, what I call workaround, mitigation, fix, call it what you want. Any particular Java application that needs to make multiple trips to the database, if it can bundle those up into something as simple as a PL SQL call, then we have some orders of magnitude benefits. So let me flick back, and people may debate this with me, but I would argue that this is a very easy migration to do. People say, oh, it's PL SQL. I don't know PL SQL. I'm a Java guy. I'm a C# guy. I'm a Node guy. But one thing I'm not saying is people should be embracing a fully fledged, what we call smart DB migration of all their code to PL SQL. What I'm saying is, if I've got simple queries like this that I know I'm going to be running 3 trips to the database, I can simply take those and relocate it into almost the equivalent, almost exact same SQL as a PL SQL routine. So I'm not saying re-architect it, I'm saying redesign the database or change the tables. It's simply, I've got 3 SQLs over here, put them into a simple API procedure, pass in the parameters, get the values out, and now my Java program, once again, I'm doing 5,000 iterations. Rather than doing 3 SQL trips to the database, I'm going to make 1 trip to the database and run the 3 SQL statements in the PL SQL program. So I'm not doing any refactoring to try to do less SQL statements. I'm still running 15,000 SQL statements. I'm just running them with less network trips. So let's go back to my... So just want to reiterate, we're doing the exact same amount of work. We're doing 15,000 SQL statements. And what do we get? Unsurprisingly, we did 5,000 trips to the database, and we took just over 5 seconds to get all the data back because 1 millisecond transfer time. And this is a good example. I'm not trying to brag about my Wi-Fi network, but it's a proof that even though we're sending probably more data across the line and getting more data back because we're getting batches of data, it's still just as fast because bandwidth is rarely an issue. It's always about latency. So literally those 3 or 4 lines of changes in this particular little application got me a, in Oracle we say 3x, 300%, 3 times performance benefit. There is nothing you can do hardware-wise, network, anything that's going to get you anywhere near that. And putting even multi-cloud aside for a second, in any data center, getting a 3 times performance benefit is not something you'll almost ever achieve with hardware. It's just unheard of. So literally 10 lines of refactoring is, a small price to pay to get a 3-fold performance benefit. Anything you want to add there, guys, before I jump into something critical?
No, I was like, wow, that's impressive. No, and I also like the fact that you threw in that, because you're right. I mean, I've heard over the years, it's like, well, we'll just throw more hardware at it. That'll fix the problem. So I'm glad that you pointed that out.
I shouldn't have got rid of the share.
That's okay.
This moves on to something that I think we were going to talk about later, but I'll do it now.
Okay.
One of the things that I was spitting out as all these demos, but wasn't talking about, was database CPU. Now, what this piece of code does is, as it starts, as well as doing the actual workload, before it starts, it measures what the total database CPU consumption has been up to this point in time, does the 5,000 iterations, and then measures again and shows us the delta. And this is something that people are often blissfully unaware of. I've done 15,000 SQL statements here, and I've done 15,000 SQL statements here. I've done the exact same amount of database query work, the thing that matters to my application. In this one, where I did 15,000 trips to the database, the amount of CPU consumed by the database was 100 centiseconds. Once again, just a blip on the landscape. But compare that to this one. I still did the same 15,000 SQL statements, yet I halved my database CPU. And the reason for this is there is a CPU cost on the database to responding to an incoming request. The client says, do something for me. The database consumes a bit of CPU to marshal its resources, to understand that, to actually go through the process and then actually do the work for you and then send the information back. There's a CPU cost for that interaction, not just the actual act of running the query. It's the interaction that costs you as well. Doing less interactions not only gets you a response time benefit, which keeps your users happy, but I've actually used half the database CPU. Now, we're Oracle, let's be open and honest here. What is database CPU to you as a customer? That's money. That literally is money. If you can use half the database CPU, your cloud bill, your on-premise bill, whatever, literally can go down by a factor of 2. That's how you pay for Oracle resources or Oracle database resources. You pay for them by the CPU.
By what you use. That's right. Pay for what?
Exactly.
Based on what you use.
So this is money. This is real money. You literally can halve your money in this particular example. And, literally, generally you won't see the savings that great because this is artificial. But yeah, the less trips you make to the database, even to do the same workload, costs you less money. And the thing that's interesting here is we saw, if I flip back to the slides, we saw that what I did was I actually moved this code into the database. So now, as well as running these 3 SQL statements, I have a compiled object in the database in PL SQL that needs to be loaded into memory and executed and parsed and interpreted, and also run the SQL statements. So it seems almost from intuition, it would suggest that I've put more code in the database. I'm asking the database to do more work. Surely it must burn more CPU. But as the demo shows, the real numbers shows, is that the actual more logic and code you put into the database, the less CPU the database will use, because you reduce the number of interactions with the database. So be aware of that. The more you can push workload into the database, the cheaper it is for you as a customer. It seems like an absolute, anti-pattern, as Suzanne was saying there, but it's not.
Right.
Literally, more database work equals less money for you to spend. That's probably one sentence you can take away from this session.
That's awesome.
Okay.
I love that I love all that information, all those little pointers, Connor. I think that's great that we don't talk about that a lot. So I think this is really helpful. Hopefully everybody that listens and joined us today will find that helpful as well.
Yeah.
I got much more to talk about. I know we're running short on time, so how are we going?
We'll have to invite you back, Connor.
Yeah, definitely.
I'll tell you what, can I share one more example?
One more example, and then we'll wrap it up.
One more example. So this isn't code. I won't, right? And so people on the call tonight will rightly assume that, well, I've architected these examples. They're little Java programs. They're not a match of real life, and this is valid. So let me share the screen one more. I want to give you a real life example. The last place I worked with before joining Oracle, I'll keep them anonymous, but they were a organization that basically allowed you to bet on sporting events, horse racing, etc. They were a gambling organization here in Australia. And to give you an idea of how much Australians gamble, which is to my eternal shame, generally on busy days, right, this company was taking in $1 million per minute.
Wow.
Now there's probably a lot of issues about ethics and morals we could talk about there, but I'll put them aside briefly. That company re-architected their entire betting infrastructure onto an Oracle platform, a in-house application. We had a development team that was all skilled in C+ and C#, but had no Oracle experience. And no database experience either, for that matter. So I was one of their Oracle sort of assistants there. So they, with all their C# and C++ experience, built themselves an application using the Oracle stack, C#, C++, Enterprise Service Bus, Tuxedo, all talking through WebLogic to the database. This is what the schematic looks like on a PowerPoint presentation. In reality, it looked more like this. As I said, it was that classic anti-pattern of every single operation they wanted to do was masked behind a service layer, and that service layer simply said, oh, you want this attribute? I go to the database to get it. You want this attribute? I go to the database to get it, without actually being any kind of work. Right. When we went, they reached out, they said, look, the response time is killing us. This has nothing to do with Multicloud. This is just in their own data center, great network, but an infinite number of operations will take an infinite amount of time. When I first got commissioned to help these people out, they had literally hundreds and hundreds of C programs for everything that happens in horse racing. A race started, a horse was scratched, new customer makes a deposit into their account, etc., etc., etc. Hundreds and hundreds of little C routines, all of which made a trip to the database and was killing them in terms of latency. This is what we did for this customer to solve literally all of their latency performance problems. We took 2 of those APIs, customers placing a bet and customers wanting to see if their ticket they bet on was a winner after the horse race finished. Because like the Pareto principle always applies, this was 90% of the traffic to this customer's website.
Right. Customers
come along, they look at what's, what sport can I bet on? But then the key thing they do is, I want to place a bet. That has to be snappy. And then they come back as soon as their sporting event is finished, and they say, here's my ticket, was it a winner? Just like we check the lottery results. We only moved those 2 APIs into the database as PL SQL routines because these people had no PL SQL experience. And we didn't do anything in terms of refactoring the code. We took these hundreds and hundreds of SQL statements that were being run and simply move them into a stored procedure. So we're still running the same volume of SQL statements. We just weren't running them across the network layer. That's all we did. 2 routines out of countless hundreds. And that was sufficient for them to go live with their application. And that was 2008. They went live, and it's still live to this day. And so, 14 years to application. And to this team's credit, they actually ended up moving a lot of their stuff to PL SQL because they simply were so excited by the benefits. But literally for go live, this might be the scenarios that you'd be looking at for moving to a system like you want to get all the benefits of multi-cloud. You might be a Microsoft customer and an Oracle customer, and you want to continue that relationship in a multi-cloud environment. It might literally be the case that you take 1 or 2 or 3 core parts of each application, core APIs, move them, refactor them to reduce the latency, and everything else doesn't matter. And that's a really common scenario in customers. So hopefully that convinces you that real customers have done this. This wasn't in terms of moving to cloud, this was simply getting performance acceptable within their own data center, but the same logic applies. Sometimes it's just tackling latency issues for a tiny component of critical parts of your application, and the job is done.
Okay, I'll go back to this is good because you're breaking it down into small pieces of things that you can actually fix. It's making it easier to fix. And I like that analogy. Look at what you really need 90% of the time. And that's a great thing to remember as well. So thank you, Connor. I really appreciate all this great information. And Suzanne is right. We're going to have you back so we can talk more about tips and tricks of improving your application and also lowering your latency and getting the performance that you really need out of your applications. So nice. Suzanne, thank you so much again. So Suzanne, this is just kind of a summary. I think it's a great summary slide that talks about in multi-cloud, the connectivity and latency and kind of sums it up.
That's right. And it's the reason why we're just putting this up really is to wrap up all the points that Connor said, because, whether you're going across, site-to-site VPN, or whether you're going to be using the Oracle Cloud solutions that we have between Azure and Oracle today, whether that's the OCI Azure Interconnect, which is a manual customer managed interconnect where customers have to manually configure it, but once it's set up, it's done. And then they have the freedom to explore other services, or whether you want to use Oracle Database Service for Azure, which today is currently specific to the database services. And this is quite different because of the fact that it's actually an Oracle managed interconnect for the customer. So going back to some of the things that Connor has called out, we've spoken a lot about latency and good. It doesn't necessarily always have to be bad either. And I think this is just really a summary of how they vary depending on the solution that you have. And I will say, we have great fast connectivity providers who partner with us. And they can really help our customers and give accurate latency predictions between their connection points and the regions that they want to connect from and to. If we looking at the OCI Azure Interconnect and the Oracle Database Service for Azure, you'll see that, we're calling out here around 2 milliseconds latency. I mean, this isn't a guarantee, of course. This is just an average of what we typically want to have. And what happens there is, like I mentioned before, is when we do a region build with the interconnect, because we have specific interconnect regions. So today we have 12. And what we're really looking at and measuring, which is an exercise undertaken between Oracle and Microsoft, is this proximity between the Azure and the OCI data centers to achieve that, this desired latency threshold, where we really don't want to be going above 2 milliseconds, greatly above that, between the, when we're actually running the application in Azure connecting to the Oracle database. Just to mention, we're not putting any joint SLAs on that. Rather, each provider has its own SLA. So Microsoft has its SLA for ExpressRoute and Oracle's SLA for OCI Fast Connect. So that's the latency part. But you'll have heard Connor mention quite a few times about network bandwidth, right? And I think this is also very, very relevant to point out that the different solutions do offer different bandwidth solutions whereby your VPN site is it's usually low. You're on the internet, therefore you're at the will of the internet, and unpredictable performance. It's not that consistent. Whereas in comparison to the third-party connectivity provider and the Azure Interconnected Oracle Database Service for Azure, we have this private interconnect method of connecting. But you'll notice one thing on the row for the bandwidth, where you've got Oracle Database Service for Azure, and this is the fact that it's unique because it's shared, but it's also auto-scaled. So it's bandwidth on demand. So for a scenario like Connor was talking about, where we really, no bandwidth, bandwidth is limitless. So it's always a limited resource. And therefore, I just want to take a little bit and talk about that, because it's incredibly important with application performance as well, because the more bandwidth the data connection has, the more data you can send and receive at any one time as well. So like you can compare this concept to like the volume of water that you can flow through a pipe. So the wider the pipe, the wider the diameter, the more water can actually flow through at any one time. And, bandwidth, it really works on that same principle. So the higher the capacity of that communication link, the more data can flow through it per second. So one fallacy as well is that bandwidth and speed are obviously, and we hear this a lot, interchanged and not actually applied correctly. So they interchange bandwidth and speed. And maybe it's because ISPs are always like conflating this, because they, the two of them, they refer to it as greater speed, when what they truly mean is higher bandwidth. And that speed refers to the rate that the data can be transmitted, right? While the bandwidth itself is the actual capacity. So using that water metaphor again, speed refers to how quickly water can be pushed through a pipe, whereas bandwidth refers to the quantity of water that can be moved through that pipe. And then we measure that through data transfer rates. So whichever mechanism you choose to connect your clouds together, I think this slide is very helpful, because it just gives us a brief overview of what we offer. Of course, there are other multi-cloud solutions as well within Oracle with different flavors, but here we're just focusing on the OCI Azure ones and the third-party connectivity providers.
Great. Thank you, Suzanne. Okay, so I know we just have a couple minutes left. I just wanted to quickly provide some additional resources. We have a database, PM YouTube videos, many of them around our cloud services. If you go to that short link, or you can scan, that will take you directly to our database PM YouTube, our cloud database services playlist with many of these videos. And if you'd like to see some other videos, we would love you to reach out to us and let us know what you're looking for as well. We do have 2 AskTom sessions from our team. The next one, if you need a break tomorrow on Wednesday, December 21st, please join Eddie and Leo. They're going to talk about top 5 things to think about when moving to the cloud. And that's at 1 p.m. Eastern time. And then, of course, next year, Suzanne and I will bring you multi-cloud happenings, and our next session is going to be on January the 24th at 10 a.m. Eastern time. You can always go to our YouTube channel to see the replays of both these AskTom sessions, or go to AskTom directly, and we'll also have the video link there as well. And oh, by the way, if you didn't know, we have an external Slack channel, and this Slack channel is a great opportunity to find out what's going on with our webcast, some new blogs that you might be interested in, or just an opportunity to ask us questions as well on your database cloud services. So we'd love for you to join us if you haven't joined us yet. And finally, I want to wish everybody a very happy new year. We are excited that you've been with us over the past year, and we look forward to being with you in 2023 as well. Okay, with that, I think we'll sign off because we've taken up the hour with everyone. Thank you so much, Connor. We really appreciate you joining us today, and we look forward to working with you and coming up with more tips and tricks for our customers. Thank you, Suzanne. Have a fantastic Christmas and holiday, and a happy new year. Bye, everyone. Thank you.
Thank you very much. Bye, Connor.